So I'm Karl Lautman, and hello. I think a number of you know that I make kinetic sculpture, and those who don't now know that I make kinetic sculpture. And I'm here to talk about a piece that I've been working on off and on for the last 10 years or so. And this is a redo of a presentation I gave back in July. If you saw this back then, raise your hand. Let me get some sense. Okay, so most of you haven't seen it. Those of you who have, it's got a very different ending than the last one. So in July, it was an update for what I had done for the last 10 years, and I had had a breakthrough, and now I've completed the piece, and that will be the finale of this presentation. So this is an example of some of the work that I do. This was a switching power supply rendered mechanically. I was commissioned to make by a company that makes switching power supplies. And this is just pornography. This was a commission by the Franklin Science Institute in Philadelphia. It's a coffee table that simulates nuclear fission. And about 10 years ago, Pololu offered this kit that I was really kind of taken with. It's a very interesting mechanism, the way it sort of moves the M&M around, but I was actually more interested in the color sensor identifying these M&Ms, and I thought that could form the core of a really interesting piece of sculpture. And how hard could it be? The hard part, I thought, was just determining what color each M&M was and moving it around. There are lots of different ways we could all think of for doing that. But I didn't want to feed them in just through a column that you see there at the top where you have to manually fill in that column. I figured I'd just funnel them down into that column because I wanted a whole big pile of M&Ms, not just a dozen or so. And so this was one of my early attempts at a metering mechanism that would extract an M&M from a column and then send it on into the machine after making a measurement. And I just figured, as I said, I just have a big funnel that would feed that tube at the top. And that was my first bad assumption, because you'll see in this test piece, those channels are just a little bigger than a single M&M, maybe about the size of two M&Ms really. And M&Ms won't naturally flow through such a constrained channel without some sort of agitation. And so I realized early on that I couldn't just funnel them away, that extracting these M&Ms was going to be a little difficult. Exactly. Oh, there are lots of well-fucked moments over the last 10 years, trust me. And so the next idea I had, this was 9 years ago, was to just take a disc that has M&M-sized holes in the perimeter and put it at the bottom of a cylinder, and then the M&Ms would just randomly fill the holes as it spun around, and then there'd be one big hole underneath one, and they'd fall through that. You just have to cover that hole to keep them all just following through.
And it worked perfectly?
And this worked perfectly, as you'll see. What?
That's how you get your gumballs at the grocery store.
Yeah, gumballs work much easier because they're more spherical. The fact that an M&M's a lozenge was one of the major problems with this.
Wow, that's really well.
Now, when I wasn't giving this as a presentation, when I was just testing it out, I could jump ahead in the video and speed it up. But in the view I've got here, there isn't any speed up control. So we'll have to sit through this a little bit.
Are those all M&Ms or are those Reese's Pieces as well?
I think I mixed in, no, these are actually M&Ms, but this was done over Halloween, and so I had a lot of leftover Halloween color ones. Yeah, sure. Yeah, they're all the same. Yeah, so I didn't intend to make you sit through this whole video, but because it actually can go much faster. Let's see, is this going to speed it up? That's going to send me to the next video. Anyway, yeah, I'm just going to have to jump over that. So the next step was to figure out how to meter them. The last one, there was nothing wrong with that, except I didn't want to sort them continuously. I wanted to meter one at a time. And so the next step was to figure out, how do I spin that disk one M&M at a time? And for that, I used a Geneva mechanism. And you'll see in a second, I'll tip this up, which is a very old mechanism for converting rotary motion to an index motion. And so by putting a Hall effect, a magnet on that cylinder and a Hall effect sensor on the stationary frame, I could command a single rotation of the motor, and that would turn into a single M&M being extracted from this thing. And so let's go to the next one.
Wait, I don't understand why you need the Hall effect sensor if you just have a rotation, if you just have that consistent rotation.
The motor doesn't know where it is.
Let me stop this.
Is that to control the speed then?
No, it's to control the motor because I might not want the motor to go as fast as it's going. So rather than control the speed of the motor, because some M&Ms I might identify quickly and some I might identify slowly, I wanted to just give the motor a pulse and give me another M&M, and then I'll tell you when I want the next one. So the Hall effect lets me do that. So I don't know if you can make out on that display, but it's telling you what the color is. And this was working fine. I'm not showing I haven't built the rest of the machine here where I'm actually sending it to different places. The key part was metering out individual M&Ms, and I'm doing that very reliably now, and determining the color.
Did you do all the mechanical and electronic design yourself?
Yeah. Let's see. So the next step was to load the hopper with a typical, what I anticipated to be a typical load of M&Ms, which was a lot more than what you saw before. And that's where I started to discover problems. And that's one of the important takeaways of a project like this, that if you're only testing small samples of something, 20 or 30, and you've got a problem that only occurs 1% of the time, you're not going to see it unless you're very lucky. And so it was only after I loaded a bunch of M&Ms that I started to discover the fatal flaw of this approach. Even though you can see how the diverter is evolving, it's getting more complicated in the 3D printing. It now has this shelf that's blocking the bulk of the M&Ms from falling on the disk, which slows it down and screws things up. But there was still a fatal flaw, which sent me back to the drawing board. And that is, every so often, an M&M would get sheared like that. And as I thought about this more, let's pause this. Let me pause this. There. I realized that any mechanism that was going to subject the M&M to any sort of shearing was going to have this problem. And all the mechanisms that I had thought of to that point, no matter how you broke them down, would have some sort of shearing involved. That was just how my mind was working. So I'm not going to spend time sort of regurgitating all the blind alleys I went down with pursuing non-shearing mechanisms, because they got more and more baroque and complicated and introduced other problems. And that's why this thing dragged out so long. Obviously, I wasn't working on this continuously for 10 years. A year, that would really be depressing. But literally.
much VC money.
Exactly. I'm almost there. But, I mean, literally a year could go by without me thinking about this at all, because I'd come up with an idea and I'd spend a week or two developing it, and then, oh shit, that's not going to work either, and I'd go off and dejected. And as I was thinking about this, as the years drag on, this sort of became a thing on the internet. Other people decided to sort M&Ms, and they were pulling it off, which really pissed me off. So this is just scratching the surface. If you Google M&M sorting machine, you'll see a lot of interesting things. I thought this was a very clever approach, but this would not scale up because that hopper that he has, believe it or not, is actually subjecting M&Ms to shear forces. And if you try to put 200 M&Ms in there, this thing is going to jam. And then this guy had a great idea. He's using the phone built into his camera to identify M&Ms as they fall through the machine. And then he's got solenoids that control these gates. And he's identifying the colors just as fast as they're falling through air. You'll see in a second that he takes pictures of them, and I'm guessing he's using OpenCV or something like that to identify them. But this hopper is no different than mine fundamentally, and we all know what the problem with that's going to be. And then here's just the final one I'll show you, someone's final exam project in some college class. And I really wish I could speed through this, so I'm not going to make you look at it. But this mechanism has the same sort of thing where they fall out and they're metered one at a time. And the interesting thing about all these videos is they look like they're working perfectly. And so I'd contact some of the makers of these things. I'd say, how do you get that to work? Because don't you have any jams? And they say, yeah, it jams occasionally. But not for the video that I'm showing you, because I've edited it and I've curated it, and I'm just showing you the runs that don't jam. So there really wasn't anything to learn from what these people were doing, unfortunately.
Reminds me of those YouTube videos where people make those like basketball shots.
Yeah, exactly. You know, and they've got $1,000 of special effects software working for them. But anyway, so that's where things stood until last summer. And I came across a post on Hackaday about a guy who runs a little business out of his house. I don't know what he does, but it requires him to kit up parts to send out. And he got tired of hand separating like nuts and bolts and things like that. So he came up with a little machine that would extract a nut at a time, and then he could count them as they went by. And it's sort of hard to tell here, but this disc is angled back so the nuts fall into it. But they fit into those holes. And it's a very gentle way to handle it. I mean, nothing's going to damage those nuts, but you could imagine putting an M&M in the right size hole. And that was something I hadn't tried before. It's basically the same disc that I had horizontally, but it's just tilted at like 60 degrees. So I quickly lasered up proof of concept. Now we're up to July of last year.
So this is what your last demo showed.
That's right. And this worked great. And I knew it would continue to work great based on my vast experience with moving M&Ms around. And so, yes, exactly. And so I decided to build a machine based on this concept.
Wait, so it's a big difference if the shear force happens after it's been fitted into a hole just by gravity?
Yes, but there's really very little shear at that point. It says you're just sort of dragging it along. You're not shoving it underneath something. It just falls through. And the idea was to just keep it falling through the machine wherever it goes. Don't like try and shove it underneath something, because that would squeeze it.
Let gravity do that.
Exactly.
And if it wasn't a good fit, like there were two, one would fall out as it.
Yes, but in that approach, it's sort of complicated. It's very difficult for two to get in like that. It's much easier for two to get in if the disk is horizontal for whatever reason.
And if the hole stays empty, that's not a problem.
Yeah, because the sensor can tell whether it's empty or not, and then it just advances to the next one.
Did you ever contact the M&M company and try to sneak in and see what they do?
Well, they don't do this, obviously. They don't separate M&Ms. They make a million red ones, and then they make a million blue ones, and a million.
They introduce entropy, they don't remove it.
You're right. Exactly. But, I mean, all joking aside, they actually have a machine that does this very, very quickly. If you go to the M&M Museum in Las Vegas.
I thought they had the second law of thermodynamics on their side.
They do, but it's complicated, trust me. And you can go there, and you can take any color of M&M, and they'll mix them together for you, or separate. I forget how it is, but I saw this machine, and they're actually printing on them as they're spitting them out. And you can hear it in the background. They don't show what's going on. You just push a button, and then it dumps these M&Ms with your name printed on them in a cup. And I emailed them asking how that machine worked, and I never heard back for some reason. So, right. So this is the sensor I ended up using out of, I'll jump ahead. There are a bunch that you can choose from these days. This one in the upper left was the original one I used, but it's like $40 or $50, and it's got a lot of pins you've got to connect.
And it's 10 years old.
And it's 10 years old. I don't care. If it works, it works. And I had one, but this one's I²C. It's $9. If I blew it up, it doesn't matter. And it worked very, very well. So that's the one I went with. And this was sort of, this was a high-level test. It's sort of the top half of the machine, like the integration test you saw before. And you can see that the M&M travels down that tube in the back, and it comes to rest on top of the sensor, which is now in a clear acrylic cage to protect it. The computer takes a reading off the sensor and then dumps it into the machine because the cage is attached to a servo. So again, very light handling of the M&M as it moves through the machine, just gravity wherever you go. And so I started thinking about what the design of the rest of the machine would look like. Because over the years, and this went very quickly because over the years I'd spent a lot of time thinking about what would an M&M machine look like if I ever got it to work. What do you do once you have the M&M? How do you send it to one of the 6 bins that you end up with? And in this approach, I was going to mill out a channel in like a 1-inch thick piece of MDF, and at each bifurcation there's another servo with a little gate that turns one way or the other to open up a series of channels to, one path all the way to where you want to go. Then when I was actually thinking about building this was a design I did many years ago. You can see it was based on the horizontal disk back when I was so sure that was going to work. I was thinking, what will the rest of the machine look like? And then I had to move on. I decided I just wanted to get this thing off my bucket list at this point. I didn't want to deal with all those servos because they were potential problem sources. If I didn't need that many, how could I simplify it? So I thought about this approach, which just had one servo moving that tube at the top to various channels. And I ended up abandoning that or modifying it. And this is what I ended up with right here.
Use computers.
Wait, hold on a second.
Oh, wow.
Whoops.
Well,
yeah. Okay, let's see if I can, if it's going to let me, hold on.
double click.
Go back to the start here. Here we go.
Double click.
feel good.
Yes, it's a relief, trust me.